Start recording.
The broadcast is now starting. All attendees are in listen-only mode.
Hey there, everybody. Thanks again for joining us for another Autodesk Inventor 101. This is Luke, and this week we are getting into assemblies a little deeper. If you happen to miss the first couple in this series, we've been talking about everything from sketching basics, projects. Last week we talked about the basics of assembly modeling, basically just using constraints to put things together. We're going to do a little bit more with constraints, but I want to make sure that we talk about weldments today and that we also talk about some of the automation tools, in particular the bolted connection inside of the assembly environment. Want to make sure we talk about welds and preparations and assembly level machining operations, just to make sure we round out assemblies, because I think a lot of people assume assemblies are pretty easy and you just put things together, and while that's true, there's a lot of stuff you do inside of assembly. So we're going to be using this model today for most everything that we do. And if you have any questions, as usual, I got James on the line who is going to be handling any questions. So just ask those in the question panel of the GoToMeeting we have going. You can see in the preview for the webcam, I've actually put some resources. So if you want to try Inventor, we got tons of great projects you can go through. You can check out all the new stuff inside of Inventor, and we also have the ideas and forums. So make sure you check that stuff out, and let's get right to it. So last week we talked about assemblies and just doing some basic constraints. And what I want to make sure people are aware of is that there's not just assemblies. There's something called a weldment, and what a weldment does is a weldment basically does everything an assembly does, and you have these for both your English templates and your metric templates, and metric has many more standards within them for weldments and just for regular assemblies. And what these weldments do is they allow you to do additional model preparation to those assemblies. So if you think of the actual fabrication process, so we'll open up one of these assemblies here. We'll just grab this base frame, and when you look at this base frame, this is made up of sub-assemblies. So I'll even dig a little deeper, and you can see, so this is the lowest level assembly. So this is a sub-assembly that then goes in higher up. So a bunch of individual parts. There's no additional sub-assemblies in here. And if you take a look here, this model was built with lots of information in it. So the preparation, so if you take a look at, I'm going to turn on some of my shadows so you can actually see what's going on here. We'll go into perspective view, and you can see that this is built with that preparation in mind. Now, the folks that built this model, they did this preparation at the part level. So if I open up one of these individual gussets here, these gussets were actually created, as a single extrusion. They put the chamfers on this, and maybe you do that at the part level, maybe you don't. It's kind of personal preference. It all depends on what you're doing. But what weldments allow you to do is they allow you to create preparations and welding and do assembly level operations that happen during that fabrication process. So I'm just going to back out of here and give a good example. So let's say that you have this sub-assembly here that you're working with, and you have all your gussets in here and they're welded in place. Then you need to maybe notch out a portion of this top I-beam as well as this gusset here at the end. You would probably weld this in place, and I'm just making some assumptions here because fabrication processes change all the time. You'd probably weld this in place, and then you would, at the assembly level, once the folks in the shop have this put together, they would then use a torch and, basically cut that notch out of here and include that gusset. So the cool thing that you can do with assemblies is you can do, when it's a weldment assembly, is you can do machining operations. So if you look in the browser here, I have preparations. That's obviously for welds. We'll talk about that in a minute. We have the welds themselves, but the machining environment. And when I activate the machining environment, basically this looks just like the part modeling environment, right? So you have sketching, you have extruding, revolving, sweeping, chamfers, loft, fillets, points, mirroring. So it gives you all the tools, or most of the tools, that you would have access to inside of a part, but you're doing this at the assembly level. And here's where it gets really cool. So just like you would anything else, I'm going to do a sketch. I'm going to put it on this top face. And I'm going to just draw, and again, all the modeling and sketching tools are there. I'm just going to put a rectangle roughly right about there. So that's going to be what I'm going to basically machine away. And just like you did with like some of your standard sketching tools, I'm going to start to project some geometry. So I'm going to project this edge of this part right here. Maybe that component there and that little, actually I can probably just get that edge if I want it, right? So I will project, if it'll let me select it. Yeah, it's not liking me selecting that. So I'll just pick that edge, and I'll just draw a line between the two of those points. This is going to be a construction line because I'm just using this for layout purposes. So now what I can do is I can do some horizontal and vertical constraints to lock this stuff in place. And that was the wrong one. If it's not horizontal, it's vertical. It's going to be one or the other. And when I add my dimension, we'll say that this is going to be 135 millimeters wide, and we'll dimension it from this edge to here. It's going to cut back, let's say 75 millimeters. And this overhang really doesn't make a difference. It just needs to be enough so that whenever I do the cutting operation, it actually removes this. So remember, this is at the assembly level, not the part level. So I'll finish my sketch, I'll do my extrusion, and you notice you don't have joining operations here. So this is where it starts to get a little different when you're working in the machining environment in a weldment. I can't join material, I can't do intersects, I can't create new bodies. The only option I have is to remove material. So now let's say that that operation is a 35 millimeter cut, so it's going to come down inside of my gusset, it's going to pass through the I-beam, and it creates that at the assembly level. Now this is pretty cool because when I finish this up now, so I'll finish this edit, so I'm back at this assembly level. Watch what happens whenever I open this gusset. That preparation isn't on the part file because this is an assembly level operation. So again, this allows you to build your models in the way that you would fabricate them. So make sure that when you think about that fabrication process and when you're doing machining, you want to do this at the right level within the assembly. I'm doing this at the lowest level because this is probably where this preparation would happen for this particular subassembly, but I could take this up 1 or 2 levels higher inside of the subassembly. So keep that in mind, that these do not affect the individual parts. So whenever you want to do, let's say a laser of this, let's say this is, a pattern that you're just going to be, doing a laser, or you're going to be doing, maybe some kind of water jet on this. It doesn't affect your individual part file because, again, it is an assembly level operation. So the machining is a really great option. The cool thing too is this does affect your center of gravity, your mass, all those sorts of things. So whenever I look at the center of gravity and the mass of this particular assembly, this cutting operation is taken into account. So it's not like it's just graphical. It's not like it doesn't actually remove material. At this assembly level, it's truly removing material. So that is the machining environment, and there's tons of operations in there. Some are pretty simple operations, so I'm going to do a couple other quick ones just so you see how they work. So I'm going to activate the machining environment, and these are only for the removal of material. So again, just like we had access to before, we have extrude, revolve, so I can issue the hole command, and if I need a hole to pass through multiple components, so this is a really interesting angle right here between that face passing through there. Let's just say you need a hole to pass through this perpendicular to this face, and it's just going to intersect that I-beam. What we can do is I can issue the hole command. I'm going to do just a standard kind of linear placement on this. We will make this a through all, and I'm going to make this a little bit bigger so we can see it. We're going to say it's a 20 millimeter hole, and I'm going to locate this. We're going to say it's going to be 50 millimeters from that edge and 200 millimeters from that edge. And you can see not only does it pass it through that component, but then you get that really specific hole cut at that kind of oblong angle of that I-beam for a bolt that would happen to pass through this particular subassembly. So it gives you some really specific pieces of functionality that would be super difficult to do any other way. I could create this hole and project it and make these components one to another adaptive, and if that would update, that is a way you could do it, but in reality this would probably get welded together. Potentially they would bore this with a really long drill bit. So make sure that again you do this at the proper level. So the hole command, extrude, fillet, chamfer, sweep. Now chamfer is something that you would more than likely do for a welded preparation. So we're not going to do this with the machining environment. So we're just going to return out of that machining environment, and we are going to go to the weld preparation environment. So the weld prep, this all looks very similar. So you have extrude, revolve, sweep, chamfer. It just stores them differently, so you have access to the exact same pieces of functionality, because sometimes a weld prep is more than a chamfer. Sometimes it may be a really complicated extrusion or a sweep, depending on what you're doing. But what I'm going to do is I'm going to prep, and I could do this to all of them, but I'm just going to do this one right now. Typically, you'd have a little bit of a chamfer on this gusset. I'll come in here. I will add my weld preparation to here. This is going to be a maybe a 5, oh, that's a little too much. Let's say a 3 millimeter preparation on that. I'll do the same thing to my top. And now I have that chamfer preparation on both ends of that gusset. I could even add that to this back face. And again, whenever I open this part up, so if I finish my edit or I open this part, none of that preparation is going to affect my original part for, again, laser or plasma tables, that sort of stuff. Remember, if you have any questions, just make sure you ask them in the question panel. Myself or James will get you an answer. He may even interrupt the broadcast here to ask the question. So if you have anything, ask that in the question panel inside of the go-to meeting. So again, switching out of the preparations, we'll jump into the weld area, and the weld is definitely different now. So you see you don't have access to extruding, revolving. You do get points and axes and work planes, those sorts of things, because sometimes you may need to create some additional work features to do things. But basically with welding, you have a couple of different options. You have a true fillet weld. So this actually creates, you can kind of see that preview in the help. It actually creates a standard fillet weld. We have groove welds, which allow you to connect one component to another. This will kind of fill gaps, those types of welds. And then you have cosmetic welds. And what these do is a cosmetic weld will, number one, it's going to save you a little bit of memory because it doesn't actually create a physical piece of geometry. It doesn't actually model the weld. So fillet weld and groove weld, these actually create pieces of geometry inside of your assembly that could potentially, increase the file size. And if that's an issue, or you have lots and lots of welds that you're doing, you may want to think about doing the cosmetic weld. If you have a pretty robust computer and you're not too worried about it, then you can stick with fillet and the groove weld. Also, you may use the cosmetic weld sometimes when you can't get the weld to actually apply because of the way the geometry is coming together, whatever the situation might be. The physical weld itself, it might not be able to generate that geometry. You may just use the cosmetic weld. So I'm going to show you the fillet weld and the cosmetic weld. So basically, what are you welding? Pretty straightforward. So I'm going to be welding this face here and this face here. You can chain these if it happens to be going around a curved edge. You can have it create the specific weld symbol if you want. You can add intermittency. I think that's the right way of saying that. You can add intermittency. So if this is a really long weld that has multiple staggered welds along the particular length, you can measure it a couple of different ways. And you can actually add a flat weld, a convex weld, meaning it's going to bow out. You can do a concave weld, meaning it's going to bow in. So very easy to do, and we're going to do a 3 by 3. And oh, my parts aren't touching. See, this is why I should have made this file myself. I'm going to cheat here, and we're going to, let's think about this. I should have checked and made sure that these parts were touching, because they have to touch to put the weld between them, and they're not touching there either. So tell you what I'm going to do. I should have checked this ahead of time. Let's finish that edit. I'm going to take this part here, and this is grounded right now, and now it's not, and I'm just going to do a constraint on that face there, that face there, and where did my part fly off to? There it is. And I will do the same thing here. I'll flush that face and that face. And that's going to be close enough for now. So we'll just hold that in place so that top face is actually, so let's ground that so it's in place. So now let's try that again. Sorry for the interruption. So let's go to welds. We'll go to fillet weld. We're going to fillet weld between this face here and this face here. We can again choose to add a weld symbol. If we want to create the weld symbol at the time, we can create the different fillet sizes, convex, concave. We can have offsets, whatever you want to do with that particular welded face. And for some reason, it is not liking that size. Let's go to yeah, let's do all. Yeah, it's not liking my weld. Alrighty, we're going to audible here. We're just going to finish edit. Let's try this again. We'll go back to here, and we'll come over here, and we have a couple other components that we can work with. My guess is the way that was assembled is what is causing the problem. So I know I actually assembled this one, so I'm pretty sure we'll have no problems with this one. So again, let's go to our preparation. We're going to add a chamfer right there. This is going to be a 5mm chamfer. So that's my preparation. And I will go to my weld environment. I'm going to do a fillet weld between this face and this face. And this is going to be 5mm by 5mm, convex, no intermittency. and it is not behaving again. I must be missing something here. So my attempt to show you the fillet weld is failing miserably.
One of your viewers says bead select and 2. Number 1, the first part, and number 2, the second.
Oh, you know what? You know what? There we go. Thank you.
Maybe you should be teaching this.
No, yeah, maybe I shouldn't be teaching this. I'm not sure who said that, but thank you very much. I was, yeah. So what did not happen, and I will explain what didn't happen. I was assuming it was happening, and you know what assuming does. When I picked, you can actually, I have to pick the second face manually. It doesn't automatically switch to that second face. So you want to make sure that you do that. So when I pick.
Luke, do you think that's because you can pick multiple faces and then have the multiple faces fillet welded to the other ones that you select?
Yeah, that's correct. Okay. Yeah. So so that is, let me go back to here. So there's my face 1, my face 2. So you can add those fillet welds, and you can do this with gap welds. Now, the difference between fillet welds and the cosmetic, I want to make sure I show you the difference, is cosmetic is just looking for a single edge. So I'll go back to my preparation, and you can do this with or without preps. So I'll add the preparation. Whether you do it or not, I don't think it makes a difference. The hindsight, you probably don't need it. I'll actually take that off because I'm doing a cosmetic weld. But what the cosmetic weld allows you to do is you basically just choose the edge. So there's only a single edge location for this. And I'm going to pick that edge. I can actually tell it how much of the area I want that weld to be. And this area is important here for a couple of reasons. It will actually take cosmetic welds into consideration when it's doing center of gravity and the weight of your assemblies. So if you do a lot of cosmetic welds that add significant amount of weight, if you don't give it a cross-sectional area, it will not add that to your the weight of your component. So make sure that if you want that to have that super high level of accuracy for CG and weight, that you do add that to the cross-sectional area to that particular one. But you can very easily come in here, add in your fillet weld size types. The cosmetic weld allows you to do basically any type of weld. So this could be butt seams, this could be edge welds, this could be seam welds with reference line. You could do surface building up, you could do back welding. So whatever type of weld you want to do, you have those options inside that fillet weld. So you can come in here and say this is going to be 5 millimeters. 5 millimeters by 5 millimeters. You can add in the different references that you need to know for those particular, and then it's going to add that particular information to that cosmetic weld, and it will chain a face. So if you do a cosmetic weld and you pick an edge, by default it just picks that one straight edge. If I do chain or loop, I can actually pick that entire bottom edge and it'll do the whole thing. Or if I select chain, it'll just get that one edge. So that's the difference between chain and loop. Loop will look at the entire loop of those touching faces, where chain actually just does anything tangent, so where these are running into one another. And again, you have all the exact same options: create the weld symbol, put in your cross-sectional area. So really, really easy to add those cosmetics and those groove welds. So that is welding, that's machining, that's prepping. Make sure that when you're doing this, Obviously, you want to make sure this information is valuable to the folks that are doing the fabrication for you. So make sure you're following whatever standard that your welders are using, or whatever your shop is using. You don't want to generate all these fancy weld symbols. And I'm not a welder, and I am by no means claiming to be one. So make sure that when you do this, that you are following the proper standards that they're going to be using and reading off of either the 3D models, or they're going to be working off the 2D prints. All this information gets pulled to your 2D drawings automatically. So make sure that you are following those appropriate standards. Okay, so getting back to our assembly. So we talked a little bit about assemblies last week. We talked about just putting things together, pretty straightforward. I'm going to go through that really quickly again with this particular assembly again, and I'm just going to kill the welds here, just because I don't want them giving me all kinds of errors whenever I start to take this apart. But I want to talk about some of the ways that you put things together inside of a assembly file. So when you're looking at this, this is obviously just kind of floating around in space. And we talked about this last week a little bit, about making sure that your components are located on 0, 0, 0. And I also want to talk about grounding a little bit too, because I think I glossed over that pretty quickly. But in this assembly, this part is clearly the base in this super small subassembly. So what I want to do is I want to find that origin plane for the subassembly. I'm going to make these visible. And what I want to make sure that I do is that I build this part on that appropriately. So I'm going to constrain to that XY plane, and I'm going to put the bottom of this on there. And I'm going to do that as a flush, so it's sitting on top of it. So 0, 0, 0 is the bottom of this plate. Then I can go through and grab the center planes and put those one against another. And now this component is totally, oh, I didn't hit accept. Let's try that again. There we go, apply. So now this part is totally locked in place. Now, some people do this, some people don't. They add a ground to this, and I haven't been able to prove or disprove this. I've tried it a couple times, but I've heard people say that if you ground your components at a high level assembly, your performance is a little bit better, because there's literally no degrees of freedom that Inventor has to calculate. And I imagine maybe if you had some ridiculously large assembly, that might be an issue, possibly. I'm not sure, but I do it just as a matter of habit. That way, if for some reason I accidentally, you've seen me do a few things on the screen accidentally a couple of times, but if I accidentally hit this and I hit delete and I lose this degree of freedom, then my assembly and everything this is connected to and placed into is now potentially going to go kind of out of whack. So I do it as just kind of a rule of thumb, and just for practice purposes. So whenever I have a part that's fully constrained like this, I come in, I right click on it, and I hit grounded. A little thumbtack shows up beside it, and that means even if these constraints are lost, this part is not moving. So that's what grounding does. It locks that into place. Now, some people cheat and they kind of eyeball things and then they ground them. I'm not recommending you use grounding to do that. You could use grounding to hold things in place temporarily, but just make sure you constrain things with assembly constraints or joints, which we'll talk about in a whole separate episode. And that is how things are locked in. Grounding is just like a precaution. Don't forget, have any questions, just ask them, or if I'm doing something wrong, again, like James pointed out and one of our viewers pointed out, I was missing something, make sure you reply. So what I'm going to do now is I'm going to use my constraints. Now this is where you may not be able to use your origin planes anymore. So now you're doing face-to-face connections, not origin to origin. So I'm going to use this top face, and that is going to be mated with this bottom face. I'm going to hit apply. It's going to move up. So now this is going to kind of hover on this face so it'll stay coincident with that face, but it doesn't go up or down in any direction. The next constraint I want to do is going to be lock this in, and I'm going to constrain that to, and I like to do it part to part. Some people do it to the origin. You can have these point in the same direction. At this point, it shouldn't make a difference. Now it only goes in one direction, and then our final constraint is going to be this one here and this one here. And depending on the way the arrows are pointing, you may have to switch between flush and mate. And those are pointing against each other, so that's going to be a mate. And now this is totally locked in place. So make sure that you, again, constrain with constraints or joints, and then ground your components. And again, only ground them if they're not supposed to move. So I've seen people ground things and there's supposed to be a certain level of freedom that joints allow you to do. So if you need something to articulate or you need something to translate along an axis and it's meant to be that way, then obviously you don't want to ground that component. You want to make sure that you put it together the right way. Okay, so now that we talked about grounding your components, and we talked about assemblies, we talked about some of the preparation, the machining, the welding, I want to make sure we talk about creating your components automatically. So whether you realize it or not, Inventor has a pretty big library of, what assembly level do I need to be at? So let's open this one. And there we go. So, so there's a content center inside of Inventor that basically has a library of just, thousands and thousands and thousands of, nuts, bolts, washers, all different types of fasteners that you have access to, so you don't have to model a nut or a bolt or something kind of rudimentary that you don't, that you're just basically ordering. Basically, if it's custom, you need to make it. If it's something you can buy, you can usually find it inside of the catalog. So this is inside of the assembly environment. There's a couple of ways to do this. So I could place from Content Center, and what Content Center allows me to do is you have access to, again, thousands, because remember, there's multiple standards within this. And I can filter all of this information by different standards, so I only see certain things. But we have everything from fasteners to, bushings and grease fittings, plugs, seals, shaft components, structural steel components, pipe and tube components are going to be listed in here. So there's literally thousands of parts that you have access to that you don't have to model. Again, if it's a purchased component, save yourself the time and the energy. So if I need to place a fastener in here, and I know some things about this size, if I know the length that the fastener needs to be, the hole size, I can come in here and browse through this and find the particular, socket head cap screw that I want to grab, or, whatever I want to find. I can basically dig down inside of here and grab the specific component I want. And that's great. It's easy, super fast way to do things. It's way better than modeling things. But even better way to do this is with a bolted connection. And what I can do here inside the design tab, and this is where all of your design accelerators are. And we're going to cover each of these accelerators in detail in other webinars following this Inventor 101, which we have 2 more weeks of, by the way. But we're going to dig into each one of these accelerators kind of by themselves. We'll have a webinar basically just for frame design. We'll have one just for shaft and spur gears and bearings. So we'll kind of break it up so that it makes sense. But the bolted connection is pretty quick and easy, and we'll show that one today. So bolted connection, it uses the information from the Content Center, and what you can do is you can place this a couple of different ways. So since these holes already exist, I'm going to place it by hole. I could place it linear, I could do concentric, I could do on point, and what this will do is it will create the hole in the geometry as an assembly level feature, like we were showing you those machining features previously. But since these holes already exist, I'm going to do by hole. First thing it asks for is the start plane. So I'm going to rotate to the bottom face. I'm going to pick this start plane. It's going to ask for the existing hole. I'm going to pick that hole. And then it asks for the termination plane. And these just kind of daisy chain one to the next. That's what I was expecting the weld to do, but it didn't do it for me. I'll pick that final plane. And now what I'm going to do that I have the start, the hole, and the termination plane, it knows it's 22 millimeters, so it's going to limit the selection of bolts based off of that hole size, so it already filters it down for me. So now I can start to add fasteners. So I'm going to come in here and start to add my fasteners. It's going to load up Content Center. And I must have, let's add a fastener. There we go. So I will go to a socket head, and I'm just going to grab this first one. And you can see it places that socket head cap screw, a little preview of it. If I want a washer, this is basically, if you're thinking what that bolted pattern looks like in profile view, I can add a fastener to the bottom side of this. I'll just grab that first one. So now I have the bolt, the socket head cap screw, the washer, the hole itself. I'm going to skip over the hole. I could add a second, washer if I needed a lock washer. I'm going to add, and it knows that the next possible thing by default is a washer. I could switch it if I didn't want a washer. I could go right to a nut, but I'm going to add a washer. And then I'll add the final nut on the opposite end. And by default, what it's going to do for me is it's going to automatically create the proper length bolt. So there's going to be enough bolt there. Now, I could go in here and modify this. I could make these longer if I needed to make them longer. I could make them, obviously I wouldn't want to make them shorter because then the bolt wouldn't work. But once I get all done with this, a couple things I can do here. If I knew this was a typical bolted connection, and in this case it's used a bunch of times, if I wanted to create this bolted connection over and over and over again, I can actually store this as a template so that I don't have to go through all of the bolt, the washer, the other washer, the final nut. I don't have to go through that selection again. I still need to tell it, where it's starting, where it's finishing, and where the hole is for location and length purposes, but all of the selection I just did here happens automatically from that template library. So you can see I have one in there that I created before. I could reuse that if I wanted. I'm going to hit apply. What it's telling me is it's creating this little subassembly bolted connection. It's creating a file name for this. It's actually generating all of that geometry. And you give it a couple of seconds, and it's going to automatically generate that bolted connection for you. This is going to show up inside of your design accelerators. And where did my bolted connection? I'm having a bad day here.
While you're looking for that, Luke,
it's there. I can see.
Someone mentions that the template has it set to a diameter of 22. And can that be modified?
The hole size is based off of the hole that you've selected ahead of time. If the hole didn't exist, you can make the hole any size you want. But because we were building this on an existing, one, that's why it didn't. It was grayed out at 22 because it's whatever that specific hole size is ahead of time. If we did this linear or concentric, we could tell it whatever hole size we wanted, and it would create that hole for us.
Okay.
Okay. And I don't know why my bolted connection is not visible. I can see it here. Interesting. I can see it there. I must be having some graphical issues today. I'm not sure what is going on with this. They are visible. Oh, why is it floating up there? Yeah, I must have had some selection issues going on because for some reason my bolted connection is totally in the wrong location. Oh, wow, that's weird. That is very weird. Okay, well, regardless, I'm obviously having some technical difficulties today. But yeah, so bolted connection is the way that I think you want to create any of your connections. It's just a super fast way, not only to access the content center, but to then also place those bolts. I obviously click something incorrectly because it's hanging out in the middle of my tube there for some reason. But make sure that you use that bolted connection, all the time when you're creating those types of connections. Okay, the last thing I want to make sure we do, we got a couple minutes here. We try to keep these to about 45 minutes. The last thing that I want to talk about with assemblies, and I've been mentioning this, quite a bit, is you've heard me talk about when you do welding, it adds to the center of gravity and it adds to the overall mass when you're creating these different cuts that are occurring as a machining at the assembly level, like I'm doing right here. That affects the center of gravity and the mass. I want to make sure you know where to access that. So in basically any assembly, you want to make sure that you're applying realistic materials. So center of gravity and mass is only as good as the person who is creating the model and if they're using true materials for their components. So for instance, and this isn't a model that I made, so you have to forgive me if it's not in there, but that's all right. I'm going to open up this part file by itself. So when I look at this part file, you can see that I have a very specific material assigned. So keep in mind there's a difference between a material and an appearance. An appearance is just the way it looks on the screen. A material, whenever I check this out, if I go to my properties, and I just get there by right-clicking on my component, Windows over here. When I go to my physical properties, you can see what the material is, what the density is, the mass, the area, the volume, the CG, all that sort of stuff. So you want to make sure that you're using realistic materials all the way down to the part level, because if you're not using real materials, that means when you go all the way back up to this level, and I'm going to hit update just so everything updates for me. Make sure that there's nothing out of date. When I go to the assembly level and I go to my properties and I go to my physical properties and I want to know what my center of gravity is, here's a couple things you want to look at. So if you want to include cosmetic welds in that, there is an option to include cosmetic welds. This is why that cross-sectional area is so important when you're doing those cosmetic welds. And all of that information from all of those different part files, cosmetic welds, welding, preparation, machining operations, will show you where that center of gravity is, and all this information can be set out to a clipboard. So if you were generating some type of report and you wanted to kind of see where that center of gravity was and you wanted to put that into some sort of report, you can very easily see that center of gravity, the mass, the area, the volume of the total parts. There is an include quantity override option as well. So if you are doing overrides on quantities of components, that to kind of cheat because you only put one bolt in but you say there's 20 or vice versa, you want to make sure that you have that checked as well. So super important that your materials are set correctly. A lot of people, when they start Inventor, they make everything steel or they make everything default because that's what the default is, right? Whenever I come in here and I do a standard millimeter part file, my default material is this generic material. So my generic material has basically, no physical properties. So you want to make sure that you don't leave it at generic. You want to make sure that you use legitimate materials so that knowing how much this is going to weigh, where the center of gravity is for any and all, and even if you get it close, like a lot of folks, at a bare minimum, they'll make their materials out of steel. So you might be using, 10 or 15 different types of steel. You may be using, if you don't need it to be ultra specific, at least just change it to steel. That way, whenever you go and create a new component, that part is going to have an accurate weight. That part's going to have an accurate weight. So now, whenever I check my properties, it's going to have a legitimate weight and volume and area. So just keep that in mind as you're building your components. Super important that you pay attention to your materials. Don't just let it be generic. You will run into problems with CG. So I just want to leave a minute or two for any questions. James, I don't know if we got any questions on the line.
Well, one is, what kind of machine is that? Do you know what you're working on?
Yeah, so this is it's actually a brand new machine, and I haven't tweaked anything yet. It is a Lenovo P50, I believe is the spec, and let me do this. Properties.
I assume we're talking about the machine that you're using, not what you were designing.
Yeah, I'm guessing you meant the machine that I was using. So if you meant the machine that I'm actually physically running the software on, there's the specs. It's I got 16 gigs, 64-bit. You can kind of see what the processor is. This is Inventor 2018. I may have a beta on here that you're not supposed to see anything. But yeah, so that's the machine. And if you did ask what this machine is, if this is what you were asking about what machine is this is like a high-speed switch for an automation station is what this is. So I'll answer the question both ways.
There you go. We do have another one, and this is more of a request, and that is, if you have time, can you put up the clip on Facebook how to make a spherical turbine?
A spherical turbine.
So I don't know if that was maybe part of this assembly or what, but somebody is requesting that. So if you have more detail on that one about what you wanted to see up on Facebook, let us know.
Yeah, either let us know on Facebook or shoot an email to me. My email information is do I have my email listed here, James? I don't know if I did.
I don't know. I know that Laurel's is listed, but I don't see
I don't think I have it listed. So you can hit me up on any one of those, Twitter, Facebook, Instagram. You can also hit me up at on Facebook. You can reply to this email whenever you registered. I get those emails as well, so I can find it that way if you want to give me a little more detail on what you were asking. So I hope this helped everybody understand, in particular, Weldments a little bit better. And again, I say this every time, folks. This is not meant to replace, like training at a training center, whether it's online or whether you're doing it at a reseller or one of our partners or somebody out there that is a training professional. This is meant to get you in the right direction, so show you some tips and tricks. But I hope you learned a little bit about weldments. Hope you learned a little bit about center of gravity, a little bit about content center, bolted connections. And if you have any requests for specific topics, I'm always looking for topics. I've mentioned a few that are going to be coming in the coming weeks. But if you have anything specific, rendering or, maybe some stress analysis, whatever it might be, just shoot me an email, hit me up on any of the social medias you see there. And I will make sure we get that stuff on the schedule for you. So with that, thank you very much for attending and checking us out, and have a great weekend. Bye now.